Here we are to see the mistakes which we can avoid. Well, many times students will do the problem right, but they will do a small mistake which will cost them a lot of marks, right? So here we are going to take some very simple examples, highlight the mistakes which you might do so that you can avoid them, correct? So first one I'm doing here is inverse of a quadratic function. So I'm going to take a very simple basic parent function fx equals to x squared, correct? And the idea is to find inverse of this function. You remember the process of finding inverse? It is simple. Replace fx with y and then write down your function as such, correct? Second step, interchange x and y, correct? So you write here x and write here y squared. Next step, solve for y. So when you solve for y here, you do square root both sides, correct? So y square square root becomes y, right? And so you can get the value of y. So what you do here is you write y equals to square root of x, correct? And many students stop here and they write this. But do you know what? This is a mistake. I would like you to see the mistake so that it is not repeated. Okay? Now, what is a mistake here? What should be the correct thing? Let me explain you and give you some time to understand what the mistake is, correct? Let me see this function. It is a function. So it can be represented in many different ways. You can represent function as tables, mapping diagrams, and so many different ways, correct? Simplest of all is the mapping diagram, correct? So let's make our mapping diagram. You remember this simple mapping diagram? And let's try to map the numbers. So we have here a function f, is it okay? And how is this function defined? It is converting these x values to fx, which is equal to x squared. That's right. So let's put some x values and get those values of fx squared. So let's say my x value is -1. So -1 will give me, square of -1 will give me what? +1, correct? And if I have a value of +1, then what will I get? +1 square is also +1, same value, is it okay? Similarly, if I have a value -2, I get -2 square, which is 4, correct? And is there any other number whose square is 4? Yes, the number 2 will also give me 4, correct? In fact, in quadratic function, every real number, positive and negative, will give its modulated number, right? The absolute number, correct? Except for number 0, which will give you just one value, 0, right? This process can continue for a set of all real numbers, right? If you do -3 and +3, you are going to get 9 for both of them, correct? So that is what your function is. Now, think about inverse of a function. So what is inverse? This is the set of domain and that's the range. But for inverse, it is like this. It is from here to there, and this is my inverse function, right? Now, inverse function will map me in the reverse direction, correct? Earlier, when I was mapping the function, these were my arrows from this domain to that range, correct? Now, my inverse is from here to here. That means, let me show you in this color. If I have to map 1, it should get mapped to +1 and to -1, do you see? If I have to map 4, it should map to 2 and to -2. Do you see that? So here, what is happening to x value? We are getting only one y value. That means something is wrong. So what is the correct way of writing? The correct way of writing is y should be equal to plus and minus of x. Do you understand? This is a huge mistake people do. They don't consider plus and minus, and this statement is correct. So let me cross this out for you. Never, when you write x equals to y square, then y is not equal to square root of x. Y is equal to plus and minus square root of x. Do you get the correct one? I would like to further explain you with another set of examples. Let's say I told you already that this is a function, right? Since it is a function, we can represent it in many different ways. It is not just the equation y equals to x square, correct? We solved it. Y equals to x square, showed you. We used mapping diagram, showed you and corrected it. Do you see that? Now, let's look into y equals to x square as a function which can be represented as a simple graph of y equals to x square. Let me draw this graph in two particular colors. So this is my graph of the function fx equals to x square, correct? Now, this is how it is, right? Now, if you have to find inverse of this function, then what do you do? To find inverse of a function graphically, you can draw a line x equals to y, correct? This is my line y equals to x, and then you can reflect it on that line, correct? So if I reflect it, and now let me reflect the purple portion with the purple portion. So I get, these are my invariant points, they lie on the line itself. And I know it's a parabola, you know it's a parabola, but not this one, right? But I'll show you this one is what. So when I reflect this, kind of like, do you see that? This is my y equals to square root of x. Do you see that? So the mistake is that if I just leave it here as square root of x equals to y and then write f inverse of x is square root of x, I actually get only one half of the graph. I don't really get the other half. Do you see that? What I missed on is this half, which is symmetrical reflection of that. Do you understand? So I missed on this half. Correct? So we have wrong answer. This is the right answer. So the correct way is both the graphs. Correct? That is how the inverse of x squared should look like. One way you have seen with mapping diagrams how we corrected it. Second way I showed you with the help of a graph, right? And then one most important thing to consider is for the function fx equals to x squared, let's look into domain and range. Now, what is the domain of this function fx equals to x squared? We say domain is equals to x belongs to real numbers. Is it okay? And how about the range? Range is that y belongs to real numbers, but y is greater than or equal to 0, correct? Because do you see this graph going up? It is equal to 0, but never less than 0, correct? This is for function, right? So what will happen if we have inverse of a function, f inverse of x? Domain and range should flip. Is that okay? So what are we expecting for inverse of a function? We are expecting that the domain should be equals to x belongs to real number, but where x is greater than or equal to 0. Is that okay? And how about range? Range which we expect is like the domain. So range is y belongs to real number. Does it make sense to you? So it has to flip. Now we can see with our graph that domain and range flips. Do you see that? Have a look. Now for a parabola y equals to x squared, the domain is all real numbers, but the range is greater than or equal to 0. But for our parabola, which is this and this, y equals to minus square root x, correct? Domain is only on this side. X belongs to real number where x is greater than or equal to 0. Do you see that? And how about y? It is approaching infinity, right? All values. Do you see that? Correct. So in either way, whether you see from the graph or from mapping diagram or from the equation as such, we find that the inverse of a quadratic function, if fx equals to x square, then f inverse of x is equals to plus and minus square root of x. Do you see that? That is what it is. Please, please, please don't forget to write plus and minus, otherwise you'll make a lot of mistakes. This was the simplest of the quadratic function. You can now look into other videos where I will show you how to find inverse of quadratic equations given in different forms: standard form, vertex forms, and the intercept, or you can say factored form. Correct? But in each case you can't make this mistake. Just avoid it and take a note of this. Okay? I hope you understand and appreciate what I'm trying to tell you in this particular video. Thank you.